you. Hi, my name is Langning. I work in SLU in Sweden.
In progress.
So I will introduce our experience on using remote sensing on detecting the bark beetle damages. And as you can see from the title, we are focusing on the early detection and basically the green attack phase of the infestations. And I will start with our study using the Sentinel-2 images from the satellite images as a background and why we designed the study in this way. And then our main focus is on the detectability using the multispectral drone images. Yes, so this is a bark beetle. And then the image below is the bark beetles go under the bark and create these tunnels, and then causing the water transportation problem of a tree. So since being attacked, a tree gradually lose the water content in the needles. So in the beginning, the tree crown usually do not show any discoloration, so it can stay green in the crown for some time. And then later they change the color gradually from yellow to red and then back with a green. So in remote sensing, we usually classify these different phases of the infestation according to the crown color. So we classify as green attack, red or yellow attack, and gray attack. As we see in the top view from drone images, the attack trees have a different color and in different phases of the infestation. And the side view is dead trees that's already lose a lot of needles. And this is the life cycle of bark beetles in Sweden. And this one explains why we focus on the early stage of the infestation. So in Sweden, the bark beetle usually start the first swarming in May. And then the bark beetles go into the barks and lay eggs. And then about 6 to 10 weeks after the first swarming, the first generation from the eggs, they become adults and fly out of the barks. And in the warm summer, for example, the summer in 2018, the temperature condition is enough for the bark beetles to develop another generation. So this generation go under the bark again and attack healthy trees. And then until later in August, the adults go under the ground or under the bark to go overwinter. So we consider this time before when the eggs are already under the bark, but before the bark beetle adults going out of the bark and spread into the healthy forest. We consider this period is a key period for us to detect the trees and remove them from the forest. And that's a way to control the population and avoid more spreading. And during this phase is usually the tree crown, when the tree crown doesn't show discoloration and is often in the green attack phase. So our focus has been on this green attack phase. How early can we detect the infestations and how many trees can we detect from the remote sensing method? Yes, and especially when consider the remote sensing technology, if we want to know if the green attack detectable, we also need to consider different platforms, and that's depending on the resolution, if that's in the individual tree level or in the large scale level, like Sentinel-2 images. And it's also depending on the sensors, like how many bands, and also the scales. And our first study is starting with the Sentinel images. And we acquired the Sentinel-2 images from 2018, and approximately 1 image per month. And these images have a 10 or 20 meter resolution. We use bands with this resolution. And in this study, we have 200 samples that are taken from the Pleiades image, and we use them as training data. And then in 19, we don't have a good image with the cloud condition, so we didn't obtain any image during these key periods in the May or June. But then we use this 78 plots that's from the field inventory. We use them as a test data set. So we train the data the 1 year before and then get the parameters, and then we test again for the next year. And then these are some of the vegetation indices that we calculate and to see how the healthy and attack trees, they separate through the season. And for most of the vegetation indices, they show quite good separability later in the season, and that's already trees died or the bark beetles starting the next generation and spreading. And we want to achieve early detection, that's for example, in May, in June, and before July. So currently, there was not good performance from the vegetation indices. So we aim to see different possibilities, and this is we call bark beetle indices that we create, and we have observed this linear relation between the red band and sphere band, and as we can see, the red dots are the attack trees. So after the tree being attacked, the spectral in the red band and sphere band, they both increase. And then we calculate this index, and then we also use pixel values from the Spruce stands to do a normalization and to even out the season effect throughout the year. So the NDRS index of the healthy plots, they stay almost the same throughout the season, and the NDRS index of the attack trees, they gradually increase and have a good separability, not only in autumn, but also earlier in the season. And using this index, we achieve mapping, and this is an example for mapping one area in our test set. And then we create a map with different time of the satellite images, and to show how the infestation spreading both from the forest border and also inner side, and gradually spreading to the surrounding trees. And using the similar method, we can also achieve this large area mapping, and this is a preliminary mapping covering the southern Sweden. And when we implement this method, and there are also a lot of challenges, like the tree species may influence the spectral performance. And also we only know that the trees are dying, but it's hard to know what caused the mortality of the forest. And also like forest borders and others structure information may also influence the spectral. So this method, we think there is also a long way to go. Like we can add some time series analysis, and also we have challenge to validate such big maps. And this is our first study, but we observed something interesting. Like it's true that we achieve early detection using the spectral difference from the healthy and attack plots or stands. But thing is, if we focus on the April, so no matter from the single bands or using any vegetation indices, they already show the separability before the attacks. So how to understand this figure? Like, can we say that we achieve early detection, or can we say we achieve green attack detection? And when I go through some study, and this phenomena was not alone in our study. And a lot of study using the satellite images, they already find the spectral difference before the attacks. So we have different assumptions. Maybe the spatial difference is caused by the forest structure, or maybe caused by the different vulnerability of the forest. But one thing we can be sure that if this spatial difference already exists before the attacks, then it's not caused by the green attack. So in the green attack phase, there is not that obvious symptoms that's captured by the satellite images. And we also start to consider what if there is no spatial difference before attacks, then when the trees are actually under attack, can we detect it? And that's how we design our second study using the drone images. Firstly, we decided to use drone images because it's have several pixels within the tree crown, and that lets us to have the focus only on the individual tree crown and do not consider any like the forest floors or the other tree species. So in this way, we can exclude the factors from different forest structure. And then we have also have a lot of field work, like time series observation from the field. And the first thing we need to know is when are the trees attacked. And then since the tree being attacked, how long time it takes from being attacked to showing discoloration. And that is a strong support of the study. And we use revisiting drone flights to cover different phases of the infestation. This is our experimental forest in the southern Sweden. And in total, we have 24 plots spreading in 6 stands. And then we put up the pheromone dispensers. They look like this. And then use pheromone to attract the bark beetles to attack the trees in the plot. And we have a weekly field inventory. So we go to the field and we count the holes on the bark, and we record if there is any discoloration, any defoliation, and the bark damages. And this experiment was going on in 2021 and from April to October. And this is the result from this control experiment. So in total, we have about 1,000 spruce are monitored, and then about 200 of them are attacked. And then we can see from this curve is the blue one is the number of attacked trees. So the first swarm starts in May, in middle of May, and then the number of attacked trees increasing gradually and mostly in May. And then the red lines is the attacked trees with visible discoloration. So we can see the time difference about 6 weeks after being attacked. Then we can observe some trees showing the discoloration. And this line is a number of trees actually show the discoloration. And in this year, we also observed the second swarm that's almost in the end of July, and about 50 trees attacked in this season. And as we see here, there is a sudden increase of the number of attacked trees. And then the blue, the green lines are when we acquired the drone flights. So we have one image before the attacks, and then we have one in June that covered the early stage or green attack stage. And then later we have in the August and October, that's in the late or bad gray attack phase of the first swarm. And some attack trees attack from the second swarm was still in the green attack phase. And this is the equipment we use to acquire the drone images. And it's a Maya S2 multispectral camera and have 9 bands that have a similar wavelength with the Sentinel-2. And then we fly 80 meters above the ground, and then we use reflectance targets for the calibration of images. And there's a lot of steps for processing the images, but we will not go into the details, and just showing some images how our forest or attack trees look like. And these are images before or after the radiometric calibration. And then from these drone images, we use a marker-controlled watershed segmentation, and then we segment out the tree crowns, and then we use the average reflectance from the crown pixels for each band. And this is how the individual tree look like. And then later we link the trees with field records, and then we group the tree segments with the same duration of infestation. And using this method, in the end, we have more than 400 segments. And this one become more than 200 trees that we're monitoring, and that's because of the revisiting of the drones. For example, a tree can be, in the first images, can be healthy without any infestation, and then in the second flight is already experienced, for example, 2 weeks of infestation. And then in the third flight is experienced 10 weeks of infestation, and so on. In the final one has experienced 20 weeks of infestation. And then this figure shows the number of trees with the same duration of the infestation. And for this study, we use weeks of infestation that we have more than 20 trees to have a stable performance. And most of them covering the first swarm, and we have some samples that covering the second swarm. Yes, and this is the reflectance we observe from the healthy and infested trees. And as fundamental information that the healthy and the attack trees didn't show any special difference before the attacks. And then gradually after, for example, in the 5 weeks of infestation, the band 3 and band 5, that's the red band and red edge band, they first show some response to the infestation. But at this time, the spectra are still overlapping a lot. So we can see it's really difficult to separate 2 groups. And then gradually in the later phase, like 10 weeks or 15 weeks of infestation, almost all the bands, they show good separability. And then this is how we quantify the detectability using the vegetation indices. So we first calculate the vegetation indices from the healthy trees. And they almost stay the same during different weeks of infestation according to the attack one. And then we use 5 to 95 percentile of the healthy samples. And we define this range as the normal case. And then if we have one tree that's showing the vegetation indices outside this range, then we define these trees are detectable and detect as infestations. Then we compare the detectability between different vegetation indices. And most important information is from this figure. So one tree experienced different weeks of infestation and how the detection rate increased according to the infestation phase. So we can see using most of the vegetation indices, no matter which we use, most of them do not show detectability or show very low detectability for the first weeks of infestation. So we say at this time, from 0 to 5 weeks of infestation, the green attack was almost not detectable, even using the multispectral drone images. And then to the 10 weeks of infestation, the best vegetation indices can detect 90% of the attack trees. So the conclusion is from the 5 to 10 weeks of infestation is the rapid increase of the detectability. And when we use our proposed vegetation indices, it's performed better in the early stage. And another information is from this blue solid line. That is the detection rate from the field based on the discoloration. And one important information comes from 10 weeks here. So at 10 weeks of infestation, the discoloration rate from the field, that's 48. That is 48%. But at this time, when we use the multispectral drone images, the detection rate is already 90. So this is evidence showing the multispectral drone images, they can capture about half of the trees in the green attack phase. So this is evidence that we think the green attack is detectable. But of course, it's depending on how many weeks the trees are in this green attack phase. And this is a question that I was asked in the reviewer phase, like is the spruce bark beetle green attacks only one that can be detectable? And because there are a lot of research going on that are related to other attacks or other insects, and for most of them, the conclusion so far is the green attack is not detectable, or the detection rates are really low. So if we want to draw this conclusion that the green attack from the bark beetle attacks, they are detectable, then we need to be more conscious and analyze why the spruce bark beetle is a little bit different with all the other insect damages. And of course, this is only the conclusion from one study. So we think we need to have the similar study in different areas, covering different years to make sure that this conclusion is trustworthy. And another important information is we observed the second swarm starting 10 weeks after the first swarm. So we conclude that from 5 to 10 weeks of infestation is a key period for early detection. But at 10 weeks of infestation, the bark beetle has already left the barks. So we cannot achieve the population control or spreading control if we can only detect it at 10 weeks. That means we need to detect the infestations even earlier. And we need to think about if we have enough time to fly the drones and get the data, process the data, and detect individual trees, and have the harvesters and go there and remove the attack trees. So to be continued, that we are planning to have the similar setup for covering more years in Sweden. And we are also work on the different cases are studied in different areas, like the situation in Finland and also the situation in the Central Europe, because the bark beetles have different generations and behave a little bit different way. And we also thinking about the hyperspectral imagery that may have a potential to increase the detection rate. And also we will need to have a good fieldwork methodology, and also including the physiological monitoring, like using the sapflows, and not only using the visible symptoms. Yes, and these are the papers that shows our result. And thank you for your attention.